Hey everyone, Anna Sims here with my project presentation on the effects of the El Nino Southern Oscillation on tornado frequency across the continental United States. So just some quick background information. The El Nino Southern Oscillation is defined through the AMS glossary, the American Meteorological Society glossary, as the global ocean atmospheric phenomenon that links oceanic El Nino events with atmospheric southern oscillations. So sort of the different oscillations within the El Nino Southern Oscillation help to sort of bridge the gap in the relationship between oceanic and atmospheric relations. So during El Nino phases of the ENSO oscillation, the waters are warmer than average, and during La Nina, the waters are cooler than average. So that's been linked to an increase in December, January, and February tornadoes, especially in the southeast. So that's what I want to look at for my research. That's something I'm interested in. But this is a picture from December of 2015, and you can see around the equator that the waters are much warmer than the average temperature. So that is a classic El Nino example. And then during La Nina, this actually was taken from October of 2020. So right now we are within the La Nina oscillation. So what that means for us here in the Chattahoochee Valley, closer to Columbus and Alabama, that means we're going to see a warmer and a drier winter across the area. Now that also means we could be seeing an increase in tornado activity. That's something that I like to look into. That's something that I looked at with this this research project rather. But as you can see across the equator, the waters are cooler than average. So right now we're in a weak to moderate, but we could be getting into strong later within the year. So why it matters: public media and scientific interest in seasonal forecasts of the frequency and severity of severe weather has grown substantially in recent years. So one of my main jobs as a meteorologist is to keep people safe ahead of and during severe weather outbreaks, and any sort of advanced warning heads up we can give people is key. So I don't remember if y'all remember last Easter, we had that Easter Sunday outbreak, and they started warning us with the Storm Prediction Center 6 days in advance. So we have the hurricane outlooks that we get at the beginning of hurricane season. If we could get something like that for the beginning of tornado season, that would just be an even better shot at giving people that advanced warning and heads up just that there could be severe weather throughout the season. So the El Nino Southern Oscillation shift is also related to a shift in the jet stream, and it's a rather controversial topic within the meteorological community, especially when relating that shift to tornado density. So not to go way too weather nerdy on you guys, but when you're on the eastern side of a dip in the jet stream, you have rising motion, and that's one of the main ingredients for severe weather to take place. So it's hoped that throughout more extensive research, we can start to issue these outlooks ahead of severe weather seasons to know how active the season could be. So the main question I had for my research project was, is there a statistically significant difference of mean tornado densities in the United States during different cycles of the El Nino Southern Oscillation? So my hypothesis was that the tornado density during La Nina would be greater than the mean tornado density during El Nino. And the objectives I used to do this hypothesis was using a 2-sample t-test to see if there was a statistically significant difference in the mean number of tornadoes seen during El Nino and La Nina in the United States. So I did the 2-sample t-test. I used La Nina years and El Nino years because they're independent of each other, and I wanted to compare the two groups independently to see if their means are different. So my design for the experiment was to take all of the years during which we were in La Nina and sort them by increasing year. So I started around 1950 because that's as far back as our tornado data goes, and I started with 1950 and then went down by year I went down with increasing year. I then numbered each year starting with around 1950 to 1, and I went to as many years as we had up to 2019 because we don't have the 2020 data yet. And then I used a random number generator in Excel to randomly select 10 years in which we experienced La Nina conditions. So I did the exact same thing using the years in which we saw El Nino conditions, and I then used Excel to find the mean number of tornadoes for each cycle as well as the standard deviation. And then I completed the 2-sample t-test in Excel using the data analysis tool pack with alpha set to 0.05. So here are my random years that were selected in that random year generator. And I also put the number of tornadoes that occurred during those years, during the different ENSO cycles. And then I have the mean, standard deviation, and the sample size in this data tables that I created. I also made a bar graph of the raw data. I used Canopy and used Python coding language to do this. That's something that we use a lot in the meteorological community. It's what I learned at UGA. It's what Dr. Gunter was going to use with me before he decided to move to Louisville for his new job. But I have the La Nina years in blue and the El Nino years in red. So you can see it looks like there's definitely more tornadoes happening during La Nina years. But you can also see that over time, we definitely are seeing more tornadoes than we used to. So I was worried about confounding variables, but we'll get to that in a minute. So I did the 2 sample t-test. I got the means that weren't that far off, which was a little disappointing, and my p-value was huge. So didn't quite work out the way I wanted it to. Not quite what I thought was going to happen, but it kind of made sense once I thought about it a little bit harder. So I got 0.5 for my p-value, which was much higher than my alpha value, and because of that I couldn't reject my null hypothesis. So there was not enough evidence to suggest a statistically significant difference between the 2 means. I do still think there's a difference. I think it's not on as large of a scale as I used. I think I should have scaled back more, but I'll get to that in just a second. So I looked at the whole United States. I looked at all 50 states across the United States, and I should have scaled down to a more mesoscale. So I used a synoptic scale. I should have used a more mesoscale to see how it is spatially. So we know that during different El Nino and La Nina cycles, the density shifts geographically. So during La Nina, we see more in the southeast, but I have a friend that works in Texas, and as soon as La Nina backs off, he's going to have more tornadoes in Texas. So it does definitely move geographically with the different cycles. So the potential confounding variables I also had with this could be climate change, the fact that warmer temperatures just lead to more atmospheric instability. So during the spring, when you walk outside and you know it's a day that we could be seeing some severe weather, you can feel it. It's warm, it's really humid, and it just sort of feels unstable. You can feel it in the air. When we start to get these severe days, I'm definitely going to make y'all think about that and go check it out. But I also could have had some data collection discrepancies. I got all of my data from the NOAA, NWS, and SPC, so they all kind of came together to make this one big chart of the data. So that's the National Oceanic and Atmospheric Administration, is sort of over National Weather Service and Storm Prediction Center, where all the data comes from. But more rural tornadoes may not have been caught in the 1950s than there are now. So that's just because our Doppler radar is a lot more advanced than it used to be. So we had a tornado last year in Clio that hit nothing but a bunch of trees. So had we not had that better radar technology, we probably would have never known about it. So there's a chance that it is because of the technological advances, and then it could just purely be because of a shift in the jet stream. So not really anything with La Nina or El Nino at all, and just that jet stream shift that causes it. So the next steps I want to take in my research is to scale down spatially and temporally to see where the difference really lies. I think probably what I'll do is look at Georgia, Alabama, and Mississippi instead of the whole continental United States, because that's kind of the region that I'm invested in since I'm from here, and it's where I want to eventually continue working. And I want to look at it by seasonal variability. So instead of just looking at the whole year, maybe pull the months for winter months that we see La Nina instead, and see how many tornadoes we see during La Nina and El Nino during the winter months. So my references are here. Obviously, it's recorded, so if you have questions, I can't answer them right now because I don't know them. But if y'all ever have any questions about this or anything weather related at all, I love talking about weather. I love talking about meteorology, so feel free to email me, message me on Facebook, anything like that is fine. So thanks you guys for listening. Hope you enjoyed me nerding out on weather, and I hope y'all have a great break.